Okay. All right. And then you can actually use the select an existing device so that you don't have to dig through the catalog. But to get that to work, you need to first make sure you can see it. So let's exit out of there and let's go to communications configure drivers, as you might be already familiar with. You're going to go to configure, make sure that you are using the USB driver. And I see right here, press close. Okay, now we can try doing that. Uh, I just created a project. Okay, now we can select existing device. And right here, we're going to find the one that doesn't have an X through it. All of these are like other instances because every time we plug this in, it's creating getting a new IP address. So those are like older instances. So let's just choose this one because that's the one that's active. Press OK. And the other approach is you could go under controllers and you can manually find it. It should be the LC20QWB version 14. Alright. So now that we're here, let's go to programs. We're going to create a new program. We're going to say add ladder diagram. So this is all review steps that we've done earlier. And then we created program one. So I'm going to double click it to enter. In here, we have our single rung. We're going to scroll until you find the timer slash counter. You see that right here? And here we have a bunch of different options. In case you want to know, you can press F1 and that's going to bring you to a help page. And you can see that here are all of our counter options. So let's review the three main ones that we're going to be looking at. We have CTD. That's going to count down, D for down. So it's going to, every time you click it, it's going to decrement. And then we have count up, CTU. And then we have count up, down. So this can do both. Uh, let's take a look at count down, our first one. So that's going to be CTD, count down. We're going to put it here. And then under favorites, which you should already have, we're going to have a direct coil. We're going to put that, we're going to put that here. Okay. So this is going to, so let's go over what each of these are. So if I go into CTD, you can see right here, we have the input CD. Then we have the load. That's going to, oh wait, countdown. Yeah, okay, countdown. Oh, you know what? Count, let me see. I think count up is going to be a better one to start with. Yeah, let's do count up. Sorry. CTU. Do the count up. Okay. I'm going to start with that one because that one kind of makes that one's a little bit more intuitive. All right. So CU, that's your input. That's what is triggering a count every single time. So in our case, we can put a normally open, which you go back to favorites. You do a direct contact, examine if closed. We're going to do the button number 1, right? So that's our going to be input number 4. Here we can also label it button 1, button 2, button 3, and button 4. We now have 4 buttons, right? Okay. Output, we have light 1, light 2, light 3, light 4. Okay. I'm just naming it. This is an alias I'm giving it. That way it's easier than me trying to say DI04, DI05. Okay. Here we're going to use the input is going to be, now that you named it, you can just say button 1. Okay, so button 1 is what we're counting. All right. Now reset, that's going to reset the counter back to 0. So we need a button that allows us to reset it back to 0. Let's use button number 4, the one that you just created, okay? PV, that is your program value. That is what you're trying to count up to trigger some reaction. So that's a number that we can just put in. You can see right here, it's a D integer. All right, so let's just put in here 10. So we're going to count up to 10. Once you count up to 10, then Q is going to be active. Up to that point, it's going to be inactive when you have not reached that value. And then CV is going to be your current counter result. So that's just kind of reflecting your count. The number counts. All right. So for now, and then for the output, let's do this. We're just going to do a direct coil. And we're going to turn on, let's just test that new button you just wired up. So we're going to do light number 4. Light 4. Okay. So this is good because it's going to utilize both the button and the light that we just wired up. Let's just make sure that works properly. Okay. So what do we expect from this behavior? You click button number 1 9 times. And then on the 10th time, Q is going to turn on, and that's going to turn on your blue light, the one that you just wired up. And then you press that blue light, and it's going to reset this back to 0. The blue light turns off, and you can do it again. Let's try it out. So if I download this, okay, I'm going to download with project values. I'm going to change to remote run. Man, these wires are getting super messy. All right. We need a panel to hide all this stuff behind. Okay. Let's take a look here. Right now, what is our count value? 0. We don't have anything yet. We are trying to reach 10. Okay, I'm gonna press that red button, which is input number. Oh wait. Oh yeah, input number 1. Okay, well, input number 4, which is button 1. I press it, and count value is now 4. Let me press it a couple more times. Count value is now 6. Now, as Tim mentioned in the video, if you press and hold the button, it only registers it that first time, and you keep holding it, nothing happens. Okay? It's only every time the button's pressed, if you think about that, rather than when it's released or if you hold it. All right, let's do 2 more times. I'm going to go up to 9. Okay, right now the CTU is comparing. CV against PV. Count value, preset value. Count value is less than preset value. This is a, once it's equal, then Q is going to turn on. And do you guys get your blue light turn on? Everyone gets a blue light turn on? Okay. There's some wiring going on if the blue light doesn't turn on. And then that blue light is our reset button, which currently says false. You see that? It says false because there's no, it's a Boolean value. Is it reset or is it not reset? I'm gonna press this blue button. It's going to make it true. And look at our count value has gone back down to 0. Uh, anyone not get the blue light to turn on? Okay. The next one, we're gonna use the countdown timer. Let's add another rung. Actually, I'm just gonna, yeah, you know what? We'll just build it manually. We're gonna go to timer and we're gonna do a countdown. And it's a similar setup, but slightly different. So once again, we need to have the thing that we're counting. We can use, let's use button number 2 this time. And then our preset value, let's count down from 10. And then the difference is here, we need to load the value into our queue. Otherwise, it's an empty queue. So instead of a reset button, you have a load button in the middle. So that button's going to tell you load the queue, and then when you click it, you're counting down. Okay, so we're going to use button number 3 to do the loading. Oh, sorry. You just have to go in here and put button number 3, or it's going to be input number 6. Okay. And then our output this time, we can just do button number 3 then. Or sorry, light number 3, which is going to be output 2. All right. Go ahead, download this program. Okay, so right now, our count value is 0. We need to load that count value with our preset value of 10. Okay. What's going to happen is once we load it and then we keep triggering, this number is going to start counting from 10 all the way down to 0. Only at that point does Q turn on. So we actually already satisfy the condition, which is why your light should be on. Your light number 3 should be on. Because you see Q is already counted down to 0. It's not going to go negative. It's just going to stop at 0. So let's reset it by clicking the button number, what is it, number 3? Number 3 should reset it. Okay, you see? Okay, sorry, I should use the term, it should load it. As you see, when I pressed it, CV count value is now 10. Now, when I press the button number 2, which is your input 5, it's going to go down. 9, 8, 7, 6, 5, 4. Let's get down to 2, 1. Okay. And as soon as I hit 0, then Q turns on. My light turns on. All right. I keep hitting button number 2. CV continues to stay at 0. It doesn't go any further down. And likewise, just like the first situation, I press and hold this, nothing happens. Well, it's also at 0. Let me just reset that, or let me load that. Okay, so I'm going to reload it. It's kind of like it's like an arcade game. Okay, they give you're buying the rounds of ammo, and then you keep using it up, and then once you're done, you can keep triggering all you want, and nothing's gonna shoot. Okay, you have to reload again. Okay, so here I'm pressing my trigger button. Once again, I press and hold. It will register it when I first pressed it, but even though I'm holding it, it still stays. It only registers again the next time it sees a press. I go down to 0 and my light turns on. Yours should be green though, or what do we do? Light 3, yeah, yours should be green. My green button is unfortunately broken. So now your other program still works. Did you notice how we didn't use button number 1, we didn't use light number 4. So we should be able to keep using that one in parallel. All right, great. You guys got that working? Countdown? Okay. Great. Now, the next thing you can do is a combination of those two. So count up makes sense, right? Let's say, what's an application for count up? Um, just counting how many people pass through a door until it's like maybe it will give the next person, it'll tell the person to stop. All right, stop and wait. Okay, so it's like 10 people stop, 10 people stop. Countdown, I gave that example where it's like you have a let's say arcade shooting game. It gives you the rounds. You're done. Okay, the next person can go in, reload, and it keeps coming down until 0. Good. All right, the next thing we're doing, I'm gonna erase these because we're gonna need to utilize the 4 buttons that we have. The next thing we're gonna use is a combination of those two, which is count up, down. So this combines both of those factors. And this is more of kind of keeping track of what's in your queue. So what's gonna happen is you can press the button to either increment or decrement. So this is like, okay, I'm pressing a button to count how many people are going into the queue. But then on the other hand, the person that is servicing everyone is going to press a button to decrement. Okay, I just took someone away from the queue. So this is going to help you keep track of how many people are in the queue at all times. That's an example. Okay, so once again, we need to put a trigger. What is the thing that's triggering? Now there's 2 types of triggers. That's what I was saying earlier. There's the trigger for when you're adding. So that's count up. You see that CU? And then there's the count down trigger. And both of those are going to constantly be undoing each other. Okay. And the count value, CV, is going to show the total number from those 2 results. All right, we're going to go to favorite. And I'm going to, for the count up, we're going to use button number 1. For the countdown, let's use button number 2. Okay, and then here we have reset. Reset is for what? Count up or count down? Yeah, reset's for count up. And then we have load. That's for our count down. Okay, so we're going to reset with button number 3. And we're going to load with button number 4. Okay, so that's why we had to use those 4 buttons. I had to have you wire that 4th button up. because we need to have, it comes on like a pairing. We have the count up with the reset, we have the count down with the low. So total of 4. Okay, preset value, let's just put 10 in here. Now I've been hard coding this number, but better practice is, you make it a integer variable, and then you can have that controlled by potentially a digital, like a keypad or a potentiometer or something. Okay, but right now we're just hard coding into the program. Okay, we have our Q, U. So normally in the other ones, we just had straight Q, which is just the output is energized whenever the condition's met. But because we have kind of two conditions, right? We have the up and then we have the down. So the QU is going to activate at what point based off the parameters I have here? At 10. Yes. The QD is going to activate when? Yeah, basically always at 0. All right. So here we're going to put, let's do let's do the same button, let's do the same light as the reset, which is going to be light number 4. That's going to be digital out 3 or digital out 2. And then here for the QD, I'm going to do the same light as the reset button or as the load button. That's going to be light 4, which is digital out 4 or digital out 3. My bad. All right. So that's kind of like the light. When the light turns on, that's telling you to press it. So the light turns on for the count up is telling you to press the reset button. And then the light turns on for the count down is telling you to press the load button. Reload. Okay. Let's download this program and try it out. All right. Currently, currently our count value is 0. So let me push button number 1. Button number 1 is going to be our count up button. All right. So I'm pressing, and let's get to 5. Now button number 2 is my count down. So look, it's going to go down 4, 3, 2. Okay, so here's the instance. 2 people entered, count up 2. 1 person left the queue, count 1 down. So we're constantly accounting for both of those numbers. Nothing is happening to our lights until we meet one of our conditions, which is for count up, it reaches 10. Like so. Now my light is on. Okay. Or my count down is 0. My other light is on. In this case, you notice we can actually get out of the 10 by, what's the 2 ways to change the value 10? Like we can press it more, it doesn't go any farther up, right? It caps out. But what's 2 ways we can change that 10 right now? Reset, okay, which is going to be the one that's lit up. That's going to bring it back down to 0. Or I could have also put count down, exactly. So unlike the other one, the instance that we had earlier, which is just the purely count up button, you can only reset it. That's the only way to get it out of the 10. And then the one with the count down, the only way to do is the load. Okay, but in this case, because we have both directions we can work with, we can have 2 options to get it out of the get it out of the specific spot. Okay, so in this case, we're at the upper limit. I can press reset. Okay. Now the other thing I could do, let's press load. Load. Okay, load. I'm going to take it from 0 to 10, like this. Okay, we're loading the queue. And if I press count up, what happens when it's already at 10? Hmm? When I'm already at 10, I can't go above preset value. So when I loaded it, it went straight to from 0 to 10. I press this, nothing happens. Okay, so I can decrement like this. Or if I want to quickly bring it back to 0, I can press the reset button right here. All right, go ahead and try that out. Does anyone need help? Okay, so now that you guys got all working, let's do something where we have the lights kind of turn on and the red, yellow, and green as it gets closer to 10. All right. So we're going to use the uh, compare function. Or yeah, so that let me add another rung. So right now I'm going to erase the output for both the count up and the count down. Let me just go ahead and erase that because we're gonna use those lights. And then right here, we're gonna do a compare. So we're gonna say when this is uh let's think about this. So I was thinking the range would be so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was thinking it would be green when it's right here. And then we could have it yellow here. And then this could be red here. And then we could have it, we could start where the red will always stay on and these will just kind of add on to each other. Meaning at this point, when it's 1 through 4 is just gonna be red, and then 5 through 5, 6, 7 will be red and yellow, and then 8, 9, 10 will be red, yellow, green. All right, let's try that. Okay. So what we could do is we can add a less than or equal to less than and equal to. So since I was saying this red condition is always going to be on at any point, right? As long as you're not 0, I guess I need to specify that. If you're 0, it's all off. Okay. So this is compounding. This is, let me just say add green. So we're actually never turning them off until you're past that, below that threshold. So I'm going to say here, less than or equal to. This first one, the I1 is going to be on the left side. Okay. So we're going to test for, what are we looking for? We're looking for the counter value. So I'm going to say CTUD underscore 1. That's the name of our count up down. I'm going to say dot. You guys use dot notation for other programming class, right? Uh, there it is. So I put in here CTU underscore 1 dot. Oh, it should be CV, not QD. Counter value. Okay. That's what I'm checking here. I'm checking the counter value and I'm checking it against the value of 10, which maybe I should have put this as a variable because these two are supposed to match. Okay, but that's okay. We're just going to do that for now. Okay, if that is true, we are going to energize. Oh, wait a sec. Less than or equal to. That's good. Okay, but then I didn't do this thing, did I? I get to do a range. Mm-hmm. Mm. Okay, I'm doing the other way. I'm doing another way. We're gonna do greater than or equal to. So once again, CTUD underscore one counter value greater than or equal to zero. All right, good. Now, whenever it's greater than zero, it's going to turn on uh light one, which is going to be digital out zero. All right, let's make another run. I'm actually just going to copy this entire thing instead of I'm just saving myself a little time. And this time, I'm still checking the counter value, but I'm checking it against the next threshold, which is uh, greater than or equal to 5. Greater than or equal to 5. Here, we're going to turn on light number 1. Or sorry, light number 2, which is digital output 1. Okay. And then we're going to do that one more time. This time I'm checking against 8, right? 8 is my next threshold. And this one's going to be the light number 3, which is digital output 2. Okay, let's see if this makes sense. So if I hide this thing right here, which just shows us the text-based programming, let's see here. If it's greater than 0, it's going to turn this off. So that means normally it's going to be off, right? The red light's going to be off. Oh, wait. No, no, no. Everything will be on. Yes. Sorry, what were you going to say? Should it be without the equal sign? Yeah. Wait, let me think. If greater than 0, yeah, not the equal sign. Oops. Is there a way to like swap this out? Hmm. Oh boy, I guess we just have to like redo it. Fine. It's greater than, oh wait, that's still gonna have everything. Oh no, that's right. Oh right, yeah, yeah. Sorry, that's right, that's right. Hmm. Okay. I don't know why I put it in here. It is here. It just doesn't show up on my screen. Yeah, because this next one, I guess I could have said if it's greater than 4, but I'm choosing greater than or equal to since yeah, so I guess that's two ways. Once it's greater than or equal to 5, then the yellow turns on, and then greater than or equal to 8, then the green turns on. Yeah. Does that make I think that looks right, right? Yeah. Okay, let's download this. Okay, once again, we're using, well, we can either use button 1 or button 2 to increment and decrement, but for now, let's just do button number 1. My light is not turning on. There it is. Okay. I had hardware issue. Number 4 and number 5. Yay, I have my orange, which should be yellow for you guys. The next one should turn on. All right, great. Now at 8, all of them are on, and they continue to stay on until we can decrement. Okay, great. How will we change this program so that we only have the light for the band specified? Did you guys get this part working at least? Okay. How will we change the program so that we only have the specific band with that one light? 1 through 4 is only red. 5 through 7 only yellow. 8 through 9 green. Yeah, there's two ways I could think about it. We can either put an and in there and then put another comparison for the other value, or I think limit integer to a specific range. Okay, right here. So minimum is going to be, in our case, 0. And then our maximum is going to be 4. Let's try this. Limit. Do I need to put a limit? Or I actually haven't used this one before. Let's see this. Oh, if I haven't used it, let me press F1. Let me see what I get here. Oh, this is not what we want. This is going to actually it's going to replace our values. We don't want that. Okay. Maybe we want a max and a min. High and low limit. Let me see here. Hmm. Okay. Maybe we'll just do the simple one. We'll just do an and. It's also good to know anyways. Okay. So we can do, what did I have earlier? We wanted that condition, right? Which is greater than 0. And then I could say here under logical, we could do and. Oh, wait. You don't need to do an and. You just literally put another, it's a ladder logic. You just put another comparison. And it's less than, it has to fulfill both of those conditions. All right. That is the and. Okay. We do that, and it has to be less than, what is it? 5. Less than 5. Since I'm not doing less than an equal, I'm just doing less than. All right. This one's going to be less than 8. And then this one is going to be less than, well, technically it will stop at 10 anyway, so I don't really need this. Okay, so I just added those two. Let's just make sure this makes sense. If your number is between 0 and 5, It's one, two, three, or four is going to turn on red. 5, 6, 7 is going to turn on yellow. And then 8, 9, 10 is going to be green. Hmm? Which one? Uh, we don't want equal to. It's going to conflict. You could do a less than or equal to, and then you could put 4 if you're going to do that way. Yeah. Now, because we're dealing with integers, that's okay. But if this was a float value, then it probably would be better to use the less than 5. Because if you have 4.9, then it was still, then it still wouldn't trigger the yellow. I'm sure there's an actual thing that gives you like a range, but it's not too bad to do that thing that we just did. All right, let's try it out. I'm going to press, right now we're at 0, so nothing's on. I press, I'm at 1, 2, 3, 4. I press one more time. Okay, your yellow should turn on. Press, press, press. And now your green should turn on. Press, press. And then if I decrement, you go back down. So I can tell just by looking at the lights, I'm somewhere between 5 and 7. I'm somewhere between 9 and 10. I'm somewhere between 1 and 5. All right. All right. You guys got that working? Single light? All right. Are we good on counters? You guys understand counters? All right. Shall we do timers next? All right. This is a good time. Oh boy, I messed up. Yeah, it's probably somewhere here. Didn't like it. Oh, use the wrong thing. Did I use the wrong thing? It should work. I was just playing with this earlier. Oh, I know. Ugh. You have to say, my bad, my bad. You have to say T hashtag and then 10S. Okay. T hashtag 10S. Okay, now my little warning went away. So right here on the board, we have MSS M HD for day, hour, minutes, seconds, and milliseconds. And then you have to do T hashtag the number and then the unit right here. Okay. Amount goes right here. Okay. All right, right now the elapsed time is 0. I'm gonna press my button. Is it not working again? Come on. Okay, there it is. Oh, actually, I have to hold it. Uh, I misinterpreted it. You have to hold it. That continues to energize it. If you don't, then it's going to reset it by default. There's another thing. There's another one, which is the one I got confused with. It's the timer on off, which will require a reset button for you to like, or a stop button to stop it. Otherwise, it's like it will continue going. So if you press it for 10 seconds, that light should turn on, the red one, right? Yeah. My lapse time doesn't show you the act. Okay, there it is, 10 seconds. It doesn't show you the. Okay. On the other hand, my other timer off, it turns on as soon as I press it, and it will turn off once I get to 0. Or sorry, it'll turn off once I get to 10. It should. Oh, it'll turn off 10 seconds after I press the button. There it goes. All right. Did you guys get that working? All right, so sorry for the misleading you here. The pressing has to happen for the timer on. It has to happen continuously. As soon as you let go, it disrupts the counting, and then it resets to 0. Okay, now it has reached 10, and the light has turned on. So I let go of the button, it disrupts it. This, on the other hand, when you press it, it starts to count up, and then it will keep counting until it gets to 10, at which point this will turn off. Now, if I press it again, I should have also, yeah, I reset it. You see, every time I press it, it's resetting it back to 0. It has to count again from 0. So I waited a few seconds, but I pressed it again. Okay, now it has to reset from 0 again. Only when it's been uninterrupted for that entire preset value, then it can finally get to that preset value and turn off. So what's an example of where you might want each of these? You can press this thing for a specific amount of time, and then that would turn off like a pump. All right. So that way you only fill a specific volume in the bucket. You don't overfill. Okay, so that's an example of the first run. The second run could be useful for at the airport, or let's just say you have a car leaving a parking garage. It has triggered this thing, and the alarm goes on, even if the car is already left. You notice that, right? Like you're walking the city, they have the little alarm going off, and then 10 seconds later, it turns itself off. All right. But every time a car goes and triggers a thing, it will turn on the alarm immediately, but then it will wait for that specific period of time. Okay, great. Let's do another example. That is going to be a combination of those two, just like we saw with the counter, where we have count up and count down. And the same thing, you can also do a timer on off. Let me make a new run. Because we've only used 2 buttons so far, I'm just gonna keep everything. Okay, so we have 2 presets time. We have the preset time of the time on, and then we have the preset of the time off. And then we have only one type of output. Let me recall here exactly. Timer on off. Okay. Delays turning on an output on a true run, and then also delays turning off the output on a false run. So yeah, that kind of combines the two, right? We delayed turning on the light, but then we also delayed turning off the light in the second run. So let's combine the two. So if we wanted the light to turn on 3 seconds after you pressed it, and then continue to stay on for additional 5 seconds after you let go, what do we need to put in here? And let's use a different button. Yes, we're going to use the third button this time, which is going to be button number 3. Okay. There's two PTs. I know it's hidden because, but it's dot, dot, dot. So it's telling you right here, PT of the time on delay, and then the off delay. The second one's the off delay. So the on delay I said for how long? 3 seconds. So T, remember T hashtag 3S. Not 3 days. No. Yeah. Okay. And then we want it off 5 seconds after I let go. All right. And this time let's turn on. Yeah, we could do the third light button. Light, which is gonna be the green one. Light number 3. All right. Let's try that out. An example. Okay, yeah. Let me play this thing. This is actually good to know. Okay, here we go. I'm going to press this button. 3 seconds later, the light should turn on. It's going to keep staying on. The timer off has not started until I let go. 1, 2, 3, 4, 5. There it is. Okay. So that combines both of those things. An example that Tim was saying is like an AC unit. So there might be a slight delay on the AC unit, but then after you reach your threshold, you would stop the cooling, but then you'll continue to blow out the remaining cool air in your system. You guys notice that? Like if the AC hits the threshold, you might notice more like if you have like a furnace, is you'll hear the difference. Like the the furnace is no longer heating the air, but then the FAC forced air unit or FAU forced air unit is going to continue to blow the residual hot air for a couple more seconds, and then the whole system turns off. Okay, so there's another example why you might want to delay. Okay, any questions, timers, and counters? Okay, we'll do some applications of that for next time. I'm gonna post Tim's video. You should watch, and then I'll do another quiz that'll be due next week on the timers. We did go over so that you kind of have some baseline understanding now. Uh, okay, and then yeah, I'll grade this stuff actually right after this. I'm gonna continue grading, and then I'll post it. All right, any questions? Okay, next week I'll see. Yeah, we'll do a couple more examples of timers and counters. Maybe we can introduce even more concepts. But I'm hoping we can make something like start making things like a traffic light, right? or maybe even get eventually to more complex things like a elevator, right? Like if you press a button and then you have to wait, request and stuff like that. See, there's a concept of a queue with an elevator, right? You have multiple buttons pressed, but then it has to hit it in an order. Okay, good job. Thanks.